Good afternoon, Mr. Milks here for another installment of video lecture notes. Today we have video lecture number 5, Voltaic cells is what we're working on today. Okay, when we are done with today's lecture, you'll understand that a voltaic cell is a form of a galvanic cell, and it's very much like a battery. We need to understand the direction of the electrical flow. We'll learn that. We'll be able to talk about some of the parts, and more importantly, where this oxidation and reduction happens, considering the name of this unit is RedOx. So that's what our main focus is today. All right, basically, these galvanic cells are batteries, and there's that spontaneous reaction that we just learned about is what's at work. And the fact that the reaction is spontaneous means the battery works without us telling it to, which is a beautiful thing. Okay, there are two types of electrochemical cells. Voltaic is what we're going to work on today. It's basically similar to a battery. The next and last video is going to be on electrolytic. Okay, so real quick, let's do some similarities of the two. They are both redox reactions, which are chemical reactions that involve a flow of electrons. Please remember that is the definition of electricity, flow of electrons. They both have this flow of electrical energy or current measured in volts. I do believe if we were in physics, we might actually measure it in amps. But let's not worry about those little things. That's not really anything we're going to have to worry about. Both have two electrodes. One's called an anode, one's called a cathode. At each one, oxidation and or reduction will occur, and we need to figure out which one goes to which. So let's do that first. That's the next page. We're going to get a new mnemonic that we need to remember. Okay, and this is the way I learned it. Red cat, angry ox. Still got the same old AN, but I learned it angry ox. Okay, with the AN there. The red cat stands for reduction will always occur at the cathode where the ions gain electrons. And remember, I like oil rig, RIG. Reduction is gaining, reduction gaining electrons. These things do stay very concurrent, so it's the same all the way throughout. We just got to remember these mnemonics. And then angry ox, the oxidation will always occur at the anode. And here we go, AN, anode, right? Reduction, cathode. Okay, see how this works? Now the metal loses electrons, so that's oil. I like oil better than Leo, right? Oxidation is losing. Oxidation is losing. And remember, ox is ox. So there we go. Electrons flow through the wire from the anode to the cathode. We got to remember that it's always going to be that way. Anode to the cathode. And the way we remember that, right? A comes before C in the alphabet. This unit's shaping up to be fairly decent as far as falling right in line, okay? So here is a picture of the voltaic cell. There's two very important things that you're going to see that you need to remember right off the bat, so I can tell you that this is a voltaic cell real quick. First things first is this salt bridge. You see a salt bridge, it's basically a voltaic cell. Also, you're going to see a voltmeter there somewhere, not an actual battery. You see those two things, and we know we got a voltaic cell to work with. Okay, and unfortunately, my touch part of my screen is not working the greatest. Now it says use table J to predict the directions that the electrons will flow. Spontaneously draw arrows to indicate the direction of the wire. Okay, so electrons are going to be lost by the most reactive element. So if I look on the reference tables and look at table J, I have to see who's higher, lead or silver. I already know that silver is on the bottom because remember that gold and silver and copper are on the bottom of this chart. So this one I just kind of remember, right? So lead is higher, so lead is going to spontaneously give off electrons. The electrons are going to flow from the anode through to the cathode. So I know that this is anode, and then this is cathode. And then I say red cat, angry ox. So red cat. So here's where the reduction happens, right? I should write reduction, not redox, because redox is both, right? And so if this is redox, this is the oxidation over here. One more step, oil rig. So oil is oxidation, so this is losing electrons. Makes sense. They're leaving here and going over there. And so this is gaining electrons. And remember, it doesn't actually go into the cathode itself. The electrons actually pass right through and come out into the solution, okay? So I just drew a whole bunch of arrows, and it basically did what they asked me to do, which is the negative electrode, and which would be the positive electrode. Well, the positive electrode is going to be the silver. Remember, I got negative electrons. They're going towards the positive. So this is the negative. Okay, explain your answer. I just did. Electrons flow towards the positive, so the cathode must be the positive one. Okay. At which electrode or in which half cell does the reduction occur and the oxidation? I labeled that real quick for you already. And which one is the anode and cathode? I did that also for you. I believe, let me just double check, because maybe I didn't write that exact words. I did write anode and cathode, we're good. And remember, they don't flow just to the actual cathode, they flow through it. Okay, a few more notes. We'll be done with this one. A voltaic cell spontaneously converts chemical energy into electrical energy, and then in the form of a current. Basically, a voltaic cell is a battery. We refer to them, some batteries, as wet cells. So your car batteries have lead storage, but there's that acid in there. So we do acids and bases. Then we get on to redox, and we can see how we can start to use these things. So there's a very high concentration sulfuric acid in batteries. You do not want to get that on you. The reaction is reversible. Okay, the disadvantage, they're heavy and somewhat dangerous. Reversible by the alternator keeps them going. Okay, so it doesn't just end, which is nice. Okay, your car battery, you don't want it to work one day and die out like your Energizer batteries would. That would be bad. Dry cells, a little bit different. Dry cell batteries, like those are in your portable radios, the little tiny, what do they call them, lithium batteries and stuff like that. Those are all dry cell batteries. There's nothing really wet going on in there too much. Okay, the salt bridge is a specific piece. It connects the two half cells and lets the ions flow between the two cells. I need to let those ions go because as they go into one, they need to balance out. The salt bridge allows for that. At the cathode, spontaneously attracts electrons. Well, it's on the right-hand side usually too, by the way. The positive electrode in the voltaic cell, it's where the reduction occurs, red cat, right? Reduction at the cathode. Reduction at the cathode. Okay, the anode spontaneously loses electrons. The negative electrode in the voltaic cell, where the oxidation recurs, angry ox. Angry ox. All right, they go together. Keeps it good. I'm going to go on. This is where you press pause to get all this stuff written down, but I'm going to keep going to keep the time down overall. And guess what? We're done. So now we know which way we're going. Oh, sorry, they're not there. You can do number 22 and number 23 in your practice packet, so you need to be able to do that. And you're going to have to be able to basically figure out which one's the anode, which one's the cathode, where's the oxidation, where's the reduction happening. And it all starts with table J, and these things are kind of building on each other. You got to find the spontaneous one first. So you guys do the practice, and I will see you guys in school tomorrow.